Now, today morning we have discussed about the KY boost converter. That is, we have taken from the paper and we have done the analysis and all. And now we are going with multi-input KY boost converter. So this multi-input same KY boost converter. I think this will be the circuit diagram of the KY boost converter which we have seen in the paper. And instead of giving a single supply, we have been justified that it has a less voltage ripple and continuous current in the inductor and then high voltage gain and stable converter and all. So this motivates us to do the multi-input. Multi-input means instead of giving single input, we gave another input but the same circuit have been modified. Okay. So I think this will be that circuit. This will be that circuit. So multi-input converter, I think we have seen with the two switches along with the capacitor, inductor and all. But here I am going to connect with the, just we connected one inductor in line with the voltage source. So by seeing that, Q1 and Q4 will on in one period and Q3 and Q2 will on in another period. So opposite arms. So the way this is the exact circuit layout we have connected by connecting the two input sources. And by connecting two input sources we have taken the value from that particular paper only. And this will be the mode of equation where first that Q1 and Q4 will be turned on and the circuit will be connected through the capacitance and it is connected to the output. And in another way Q2 and Q3 is connected. So while we are seeing that my Q2, the circuit, the current will flows from Q2 will be turned on and it will go to that buffer capacitance and then output inductor to the load. And another way from the circuit VL2, it will go through via the inductance to Q3 and then it will connected to the output capacitance. So these are the two modes of operation identified from the KY boost converter. We have seen with only two switches, but here with the four switches to connect the two inputs, one V1 and V2. Two input source have been taken into the account and it will be connected. Okay. So we are solving the mode equations, and while we are been taking that, we have considered the current flowing through the inductor and the voltage across the capacitor. This will be only taken into the account. So this is the general states equation Ax plus Bu and y equal to Cx plus du, that we obtain the state space equation by taking dou I Li by dou t, that is input inductor, L naught output inductor, then the voltage across the capacitor and the output voltage, and this have been taken and the stability state space equation will be taken into the consider. But while we are going with the MATLAB, this is the exact circuit. This is the circuit have been developed. So the same circuit only. While we have connected the extra two switches, inductor, and this is one input voltage sources and this is another input voltage source. Okay, and two input voltage source we have been connected, and that is been V03 and V04 are two input voltage sources. Input is we have given 25 volt and here also 25 volt. And while we are seeing the switching pulses, and while we have seen that 195 kilohertz, same thing have been taken into the account, 50% and phase delay is 0. And while we seeing in the opposite arm, the values will be similar to that, 195 kilohertz, 50% and phase delay is 0. And while we are seeing P4 and P3, we have given the 20% of the phase delay, 1 e power minus 4, and this is 1 e power minus 4. The remaining and all same value only. We connected two voltage sources, and now while we are running the simulation, I think sir also mentioned a model configuration parameter. In the solver, always use this trapezoidal solver along with the stiff solver along with the stop time you may mention here. Okay, apply. Okay, and once we got, this is our output voltage across the capacitor. Okay, around some 75 volt we are getting. Okay, that is 25 into 3, 2 minus d by 1 minus d. That is the output voltage equation, 25. But here I want to get that same phenomena like that. ID data only we are going to use, but we are going to use in another way, not in the previous way what we have done. Just we have written the codings, and from the codings we have observed. But here we are going to use one of the app in the MATLAB to obtain the pole zero plot, time plot, as well as Bode plot, frequency response, step response, everything we are going to obtain. So that simple procedure is there. But what is the thing now? Here two inputs are there. So two inputs are there now. We have to go for the simulation, search for ID data. You have to take it for ID data sync. You just choose for twice the time, and while you are choosing, you give the name, one as a data 1 and another one as a data 2, because that matrix will be available in the command window. So you choose one scope, and output, you connect output here. I think output for both the thing will be same only, so output will be connected here only. Similarly, the another input is here and output is also same. Okay, so the circuit we have taken, while we are seeing the same circuit, KY boost converter only we are taking, but with a multi input along with that we didn't change any other thing. So then once you run it, okay, we have to give apply, we have to give apply. And always choose this power GUI also. Okay, once it is done, we have to go and check on the command window. We are getting the two matrix, data 1 and data 2. Okay, so after that we have to go for plots, not plots, sorry, apps. We have to go for apps. In the apps, one of the most important is system identification. System identification tool is there, and there you choose import data. In that import data, choose data object. We have two data object, data 1 import. Okay, similarly we have one more data object is also there, data 2 import close. Okay, and one more thing, we can do the frequency domain also. Actually, you may search this. It's one of the important tool, system identification tool. In the system identification tool, whenever we have the data in the time domain, we can convert that data into the frequency domain. That is also possible. So after converting into frequency domain, we may go with some, if I want to remove the unnecessary things, I have an option of estimate, that is the filtering option is also available. Filtering option is also there, so it will remove the unnecessary things, that we can do. But for our circuit it's not required. Okay, if I want to remove any other thing, I can remove. Okay, so here I have to find out the transfer function models. Okay, number of poles. Actually in this totally first mode we will take 2 component, and second circuit we will take totally 5 energy storage element only there. When you go with that, we have 5 energy storage element, 1, 2, 3, 4, 5. So the way we were been seeing that, to estimate. Okay, then we can find out the transient response. We can find out the frequency response in the Bode domain. Zeros and poles we can find out. So not only that way, this is also the another way to obtain the without writing any coding. Without writing any coding, we can obtain this. So here I can take data 2, I can put my data 2, working data here. Again I estimate the transfer function models. You give with 3 number of poles, estimate, and we can get the again transient response, frequency response, and pole 0 poles. Why we are getting to differentiate data 1 and data 2, it have taken the two different colors. So we can here, and 2 LTI viewer we are obtaining all these things. Okay, so this is one of the important tool where we can do all things. Not only here, when you see that state space models will be there. Okay, actually when you have to give two inputs are there, the state space model is asking about a single input and you can estimate the state space model, and all these things you can see use this. Whatever, I think we are all need a transfer function model and a state space model, so you may go through this. So this has also been with the help of this particular thing we have seen to view the Bode response and the pole 0 plot. Okay, and next step we are moving. Actually we have obtained the sinusoidal waveform there. Okay, similar way this is also a multi-input KY boost converter. Same inverter setup, we didn't change anything. Same inverter setup with the same phase delay we have given. Same phase delay given. And then we have used we just run the waveform. So around 350 volt we were getting. Actually when you see to that, my input voltage is 50 plus 50, 100, because while I am seeing in both the equation, both my voltage will be get added up only. So 2 minus D by 1 minus D, if I calculate, my value will be 3 when I put D equal to 0.5. So almost 50 plus 50, 100, 100 into 3, 300 volt, nearly we get the values. And this is about the waveform of 3 phase, and this is the current waveform. This is the current waveform. Okay, and this is the first circuit. Then next we connected with the invert. Then third we have going to create a disturbance. We are going to connect a disturbance. A disturbance in sense, when I am running my circuit, when you see to that, actually this timer function is not available here, but it is there, 0.101. Okay, and when I give it timer 0.510, that means one point it will be connected, another point it will not be connected. That means we are just varying the supply voltage. We are giving at one point will be around 45 volt, and another point 60 plus 12, 75 volt. So we created the disturbance till 0.5 period, 0.5 second we created the disturbance. So this particular circuit, how it is working under the disturbance circuit. So even though when you see to that, our voltage is also get that means whenever I am changing my input, there is a change in the output. That we are going to prove here. Change in the input is also be reflected in the output. And when you see to that, in the 3 phase also, we may correlate that, you can see that there is an increase in voltage waveform at 0.5 volt, 0.5 second. Similarly, in the current waveform also, we have the same thing. There is a change in 0.5 second. So if this condition occurs, this is about a non-linear source, because why we gave this non-linear source now, we can't assume that when I go with any kind of input like renewable energy, it will not be a constant input. So for that we are been always doing with the variable sources. So here we are giving with the PI controller. We are giving with the PI controller and PI value and all. And again when you see to that, one is with the repeated sequence and another with that. So according to the AND logic, this will be always enabled. Whenever this sequence is enabled only, it will be fed to the switches. While we are giving the switches, again the configuration is about this 2 will be turned on at one time and this 2 will be turned on at another time. So even when I am running this condition, again the PI controller somewhat it is settled. You can see to that at 0.5 second there is an increase in voltage and it get settled at somewhat it gets settled. And again when I see to that AC waveform, this will be the AC waveform. This will be the AC waveform. So with the PI controller we have been developed. After PI we move on to the FLC. This is a challenging part of connecting solar and wind. So solar and wind we always choose the permanent magnet synchronous generator with the pitch angle and wind speed almost 11. We have kept the constant value, but we all know that it's not a constant one. So we fed here, and after giving to this wind we have find out the voltage, and it's a AC voltage. So we gave to the rectifier, okay, 3-phase bridge rectifier. After giving the rectifier, one input is given to this inductor and another input is given via the solar. Solar, it have taken the insulation level, that is a constant insulation level, and the current in the PV, both will be fed to the PV module. And after fed to the PV module, we calculate the PPV also, power. And here we have used the same inverter setup, and we use the fuzzy logic controller. So fuzzy logic controller, morning we have developed one F1 controller. So the procedure for fuzzy logic controller is a very simple procedure. We are not going to write the code once again. Fuzzy, we have to put fuzzy, and in that fuzzy, once the file is created, file, import from file. From file we have to give it what's the file name, that is F1 fizz, that we have to select it. After selecting that, we have to export to workspace. Export to workspace. Once it is given in the workspace, F1, so automatically the file will be created here. Once you created, then you run the file. Without, you have to give here also F1. F1 you have to give, and then you have to run it. And here also the same logic. Subsystem, every time there will be a logic while we are getting one from the repeated sequence and another from, this is always enable logic. Whenever it receives the input, it is working under the AND logic, it will send the signal to the pulse. Okay, because here why it is getting delayed, not due to the components like wind arrangement, solar arrangement and all, we gave the input, so it takes some time to run. Actually, comparing to other converter, we always face a problem like loop, septic converter and all. Sometimes it won't work properly. But when I go with the KY boost converter, negative response of the KY boost converter is also good. Not only KY boost, that is KY buck boost converter is also available. So that particular author, the HK, he has been developed this converter, so it have a more stability. So that it's easy for us to do the research in this area. Okay, when you see to that, this is our output, so somewhat it gets settled, and while we are seeing to this, this is our AC voltage waveform and current waveform. So one simple concept makes us to do from the normal KY boost converter, we have taken KY, analyze always in this choose one converter which is feasible for you. Choose one converter, do some modification, and check the Bode and pole zero plot. Bode plot, pole zero plot, pole zero. This always ensures your stable converter or stability. It will always gives the stability of the converter. Once it have been ensured that, you may check with the giving the input and check with the output. Okay, then give the disturbance in the input side. Give the disturbance in the input and check the output. Disturbance in the input, check the output. While you give the disturbance in the input, if you check the output, then automatically you need some controller. And in the controller, you may choose PI, FLC, or so many controllers are there. And then there you can choose the parameter all like that, rise time, settling time, fall time, steady state error and all. You may conclude your converter is a suitable converter. So identification is very important though the flow of converter. So choose one of converter and always go in the step. Always check, give the disturbance. In the disturbance it should be reflected in the output. So this is the, so I have chosen the converter of KY boost. I have done the modification of multi-input. After finding multi-input, I ensured my Bode and pole, it's been stable converter. Then we checked with the disturbance in the input and we have observed the disturbance in the output, and then we go for the phenomena. Okay, this is always have this flow, then automatically you may get the output. Okay, actually now I want to tell you apart from this, I think it will be very useful for you. Before entering into that, you may go with analysis also. So you just see, this is under transient condition. We have checked all the response. Then using PI controller, it got settled. Then we have observed all this voltage, output voltage, phase voltage, line voltage. It's all very normal formula only. We have been checking with our output. Then we use the fuzzy logic controller. Okay. Now, just as a faculty, we always easy for us to write the paper. So normally I go with this two AI tools. Actually, while I am doing my PhD, it is not that. But now, if I want to write any paper, it will be one of the easiest tool for us to sort out. So I will tell you how to do that. If you want to do anything in your research, you may go with this idea. So write, just search LSIT. Okay, you have option of LSIT. This will be always available. LSIT A for scientific research. Just choose this tool. Okay, and you just sign in with your Gmail ID. Gmail ID is enough for you to sign in. Okay, so now we need, actually it is asking about something, FPGA versus Arnold. So we will write, find a multi-level converter or multi-level inverter with for BLDC motor. I am just searching for BLDC motor. This is my, this I am going to write this paper. So I am just giving the search, find some topic I am just giving. If I give some topic, automatically it will fetch almost all papers. Not all papers, around you may get it so many papers. So here when you see to that, it will automatically give the below columns. You may see to that, I can add the column. If I want to add any new column, actually default it will choose some column. If I need technology, it will fetch the data, add column, technology. It will find out the technology. Then Specification of BLDC. Specification of BLDC. If it is available, it will search. We need not to search everything. So you may add up the column. So this is one of the easiest tool where using this LSIT we may search the paper and it will give the corresponding columns also. So when you go with that, it will ask for more papers, not only see, it is almost giving for load more papers, it will load all the papers. So this is one of the important tool. You want to compare anything or you want to fetch a data, this particular tool will be helpful. The next one is ChatDoc. ChatDoc will be very useful, and when I go with this ChatDoc, you have to again ChatDoc, you have to sign in. You sign in with your mail ID. And you upload. You can upload any papers here. If you can't able to find out anything or you are not interested to study the paper, you automatically upload the paper and you ask some questions. It will answer. So we as a human being, we are being tired by reading so many papers. So that it will being that ChatDoc will always do that. You just give the upload. Yeah, upload files. Yeah, upload. I think here, when you see to that here, advantage of KY Boost. KY Boost, it will automatically, it will search in the paper, advantages of KY Boost. It will identify, you need not to go through the entire paper and you need not to study. It will be studying that. What is the unique feature available? Feature available. Any question you may ask, it will answer that particular question. So this 2A tool will help you a lot to write the paper and communicate with the paper, and it will answer through the AI, because AI will help you to write your paper or thesis, whatever may be, it will help more to do. So hope identify, actually I am telling in terms of my own field like power electronics, but in your field, whatever the field, find out one basic paper, one base paper, and from the base paper you try to add. So actually sir have explained the Shepard converter on first day. That what you do, you have one converter, add that Shepard converter with your converter, and then you do your process. So the results only speaks here. You give the disturbance, change the load, instead of R load, change into RL load, connect one shunt filter approximation. All this you can do it. Okay, I think this will be my thing. You want to do the MATLAB, I'll show one by, because morning some of them were stopped there itself. If you want to continue, you may continue. Okay.